Hey guys. So today we're going to be doing some common lessons, talking about domains of functions and how to recognize functions from graphs and tables and whatnot. So stick around and start a timer. And once we give everyone a chance to log in, we'll get rolling. Zoom updated its software. So here we go. Morning, guys. We're going to give everyone a few minutes to catch up. Let me go and put some notes on the screen. People are just clipping through. So hope everyone's doing all right. Let's see. For those of you that are here in the live, you might want to go ahead and pull up your the con lessons and whatnot that we're going to be going through. I intend to work them and try to make as few mistakes as possible and describe my thought process and give you some tips on how to do better than I might do. Go ahead and pull up my first lesson here. So get rid of you. You know, I'm going to just go ahead and stop the timer. All right. So I posted some notes on Classroom that included pictures of this particular problem. So what it's asking us to do is determine for each x value whether it is in the domain of function f or not. Okay, a lot to unpack there. So as soon as you guys hear the word domain, you should be thinking x values. So when they have these values here, -7, 0, and 7, what you're going to do is decide, or actually just figure out if they don't mess up the equation. So what we're going to do is we're going to be taking this. I'm always yelling at my second stream. Anyway, we're going to take this function here and we're going to plug in these values for x. So, like, we'll do it in orange first. So that'd be f of, so the function where x is equal to -7. So now we just put a -7 in for the x's. So it'd be -7 on top, and it'd be -7 minus 7 on bottom. So this is sort of like saying y equals, so -7 again, okay. -7 minus -7 would be -14. So -7 divided by -14. I mean, you can simplify this to say say 1/2. So y would be equal. Okay, so what this is saying. So here's what we just figured out. So when x is equal to -7, y is equal to 1/2. Now, I don't really care that it came out to 1/2. That isn't special. But the fact that it came out to anything at all is. So we're going to say, yes, that's in the domain. As long as it comes out to be something not weird. Then that is a part of the function. Okay, so now we're going to rinse repeat that exact same process for these other values of x. So let's do a different color and let's try this one. Same process. So f of x, the function when x is equal to 0 would be 0 divided by 0 minus 7. Okay, well, that would be 0 divided by -7. And anything, 0 divided by anything is 0. So y would equal 0. Okay, so what we just learned is that when this function is at 0 for the x value, it's also at 0 for the y value, which is fine. 0 is not a weird answer. Zero is just a number, guys. All right, so let's try this one. So what about when f is equal to 7? That'd be 7 over 7 minus 7. It's a lot of sevens. Again, all I did there is I took the 7 and I plugged it in for this x and this x. And of course, that's this x. Okay, so the function when x is equal to 7 So this is basically y equals, so this would be 7 over 0. Aha, now we've got a problem. Divided by 0 is undefined. Trying to fit it on the screen. Undefined. So we don't have a y value, and that's strange. So I would say that -7 is a part of the domain, 0 is a part of the domain, but as soon as you say that that x equals 7, things get really weird. Yep, that's the right answer. Okay, so there's a square root in this one. Interesting. All right. So what we're going to do is the same exact method we were just doing. So I'm going to start chewing through this a little bit faster. Okay, so this would be because these are our x values. The square root of -8. You can't do. I'm gonna go with no. I don't think so. I'll learn if I'm wrong, but I don't think so. Square roots of negative numbers are imaginary numbers, so I'm gonna say that's not in the domain. There's no number that you multiply by itself and get a negative value. I mean, the best you could do is say that this is the square root of -1 times the square root of 8, but still, I'm gonna go. My instinct is saying no. So this one, the square root of 8 times 0. So that'd be the square root of 0. Well, 0 times 0 is 0. I'm okay with 0 being an answer. That's fine with me. So for this one, that'd be the root of 8 times 2. That's the root of 16, which is equal to 4. Or you could argue 4 or -4. Either way, I think that's part of the domain. Yeah, okay. So yeah, square roots of negative numbers, no bueno, no good. Okay, let's try this one. So we're checking domains. Here are x values. So this would be -4 minus 4, which is -8. That's fine. This one is 0 minus 4, which is, and again, I'm just using this part of the equation, which is -4, and that's fine. This is 4 minus 4, which is 0. I think they're all fine. Yep, I would say they're all good. Yeah, as long as I don't come with an undefined fraction or like an imaginary number that's the square root of a negative, I think we'll be all right. Speaking of chat, okay, so for this one, okay, so this would be -6, -6 plus 6 over 2. This would be 0 plus 6 over 2. And this would be 2 plus 6 over 2. This would be 0 divided by 2, which is 0, which is fine. This would be 6 divided by 2, which is 3, which is normal. This would be 8 divided by 2, which is equal to 4. Nothing weird here. Nothing came out bizarro. So they're all fine. And I'm going on to my next lesson. So the next one I had you guys signed up to do was determining the domain of a function. Let's try it. Oh, this is a lot longer. Okay, so we've got a function f of x is equal to x over x minus 7. What is the domain of f? Okay, so I guess this is sort of compounding the last lesson. We just want to make sure okay, that's all we need. We just need to make sure that it doesn't come out undefined. So as long as x isn't 7, I think we're okay. Because if 7, it'd be bad. If 7 was in the x spot, we'd end up with 7 over 0, which is undefined. So x cannot be 7. So as far as I'm concerned, I'm pretty sure this is the answer. Because as long as x isn't 7, it'll come out to be something that is just a number, and it's fine. Yeah, okay. So cool. Okay, so in this one, okay, we want to make sure it isn't imaginary. Okay, so hang on, let me get rid of this. Okay, so as long as x is positive, we should be fine. Yeah, as long as x is positive, so which one of these says x has to be, yeah, I think that's the one we want. Yeah, so let's just keep it positive and we'll be good. Yeah, okay. As long as x is 0 or greater, we're fine. It won't come out to be weird. So I guess here's where my brain's going here. I'm wondering, is there a way? Is there a value for x that would either make this and if we can think of one, we just need to avoid that thing. Okay. So no, I like to think. Okay. Stop it. I keep trying to draw and it just keeps changing. Okay, so imaginary is the square root of a negative value, and undefined is anything over 0. Like those are the two things we don't want to have happen. If x was, I mean, at this point, just looking at this is just x minus 4. So if x was anything, it would just come out to be a number. So I'm pretty sure all real numbers would be fine. Yeah, there it is, E. All values are fine. Yeah. I can't think of a way. I cannot think of a way that we could make that either imaginary or undefined. So is there a way, so let's see, is there a way that this could either be imaginary or undefined? Okay, since this is a fraction, I'm leaning towards the undefined part. So what would be, but it's not in the denominator. So, well, this is just critical thinking. Is there anything we can put in for x that would make this a problem? No, because even if you put in a -6, you just have 0 divided by 2. And anything divided by, 0 divided by 2 is fine. The answer is just 0. So no, this is going to be all values are fine. Yeah, there is not a single value I can put in for x there that would make that an undefined fraction. Okay. Finish that one. Let's see, domain word problems. Okay. I have to do a bit of reading here. Pooja's plant began sprouting 2 days before Pooja bought it. She had it for 98 days until it died. At its tallest, the plant was 30 centimeters tall. H depends on T, models the height of Pooja's plant in centimeters, T days after she bought it. Huh. Okay. So, this one's going to take a little more concentration. Okay, so let's see if I can persevere in solving this one. Which number type is more appropriate for the domain of H? The question had to do with days. I think since we're counting in days, I'm going to go with integers. And not just, I don't need decimals or fractions, so we're counting days here. Oh, my drawings aren't going to come with me, so I better clear those. Pooja's plant began to sprout 2 days before Pooja bought it, and she had it for 98 days until it died. At its tallest, about 30 centimeters tall. Height depends on time, where T is days. Okay. So the domain, like so. Rereading. She had it for 98 days. It lived for 100 days because it started sprouting 2 days before. But it says right here, H of T models the height of Pooja's plant in T days after she bought it. So anyway, so if I look at the instructions here, it says the domain of the function set of all inputs for which the function is defined. In this case, the input variable T represents the time. So even though it's talking about days, since we're dealing with time, that's going to be real numbers. And they're saying the lower bound part of the graph would be -2 since it did start running 2 days before. Okay. So let's try one without hints. Okay, so let's take on that and learn from it. Mason stands on 5th step of a vertical ladder. The ladder is 15 steps, and the height difference between the consecutive steps is 0.5 meters. That's a lot to take in. If you're like me, you like to draw things. So he's on a ladder. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And he is on step 5. 1, 2, 3, 4, 5. Okay, he's on the 5th step of a vertical ladder. It's 15 steps. The height between them is 0.5 meters. So it's height depending on n being the number of steps. If Mason went down the ladder, n is negative. Okay. Well, integers are supposed to be whole numbers, and each one of these steps, we're counting n steps. I'm going to go with integers because we're counting n steps, and you can't take half a step of a ladder. You either take one step or you don't take any steps. So I'm going to go with integers. The low bound would be -5 from where he's at, and the high bound would be, I think that looks right. I'm going to go with my instinct to see what happens. Cool. Okay. So from where he's at, he can go down 5 or up 10. Yeah. Okay. I get it. So now I'm just engaging full repeated reasoning skills right now. So I'm on the next one. The altitude at which we boil an egg affects how long it will take an egg to achieve perfect hardness. This I know. I've heard on so many cooking shows. It takes 198 seconds to boil a perfect egg, the lowest place possible, the edge of the Dead Sea, which is an altitude of negative 418 meters. The peak of Everest, okay. Huh. That's not a big difference in seconds, really. But okay. T of A models the time in seconds it takes to boil a perfect egg at an altitude of A meters. All right. Sure. Which number type is more appropriate for the domain of T? Well, anytime it's time, I think you're going to go in real numbers because time is, I mean, you can get down to milliseconds. So since it's time, I'm going to go with real numbers. And the domain would be anywhere between 198 seconds and 209. So which one of these says in between 198 and 209? That looks right. Yeah, the domain is time, not altitude. So I picked real numbers. I thought it was time. Oh, but we're talking about the domain. Duh, not the range. Okay, so I was right. I had everything straight in my head, but we're talking about the domain, the domain, the domain. So the domain would be, that's the range. So the domain would be between -148 and this one. Yeah, okay. So keep that straight. So domain is the x values. Duh, okay. Me is rolling a pair of 6-sided dice. Okay, sure. Uh, the probability of the sum of dice is n. Which number is more appropriate? Okay, well, this isn't like time, so I'm going to pick integers with respect to this one. The probability of an event with the sum of the dice is equal to n. Okay. N is the sum of the dice. P is the probability n, and we're talking about the domain. The domain is the x value is n, so here's what I'm thinking. The domain is x values, and in this case, x is the sum of the dice. So when I think about two dice, it is two dice, right? A pair of 6-sided dice. Okay. So I just need all the possible sums of two dice. I mean, it's like that, just the mouse clicking things. So So that's what I'm thinking. What are the n sum values of 2 dice? So the most you could roll is a 12. Because that's if you roll double sixes. And the least you could roll is a 2. Because that'd be 1 plus 1, right? If you're rolling 2 dice, that's the smallest you can roll snake eyes. So I'd go with this one. Sweet. Thinking is fun. I gotta try that one. Well, the first one, I legitimately did miss one, so I want to try it again. But the stream is on. We're almost up to half an hour now, so I think I am going to go ahead and move along to the last two, which is these go so much faster. So recognizing a function from a graph, as long as they're not, as long as we're not doubling up on x values, then it is like this one. You'll notice that the graph never, like if I were to take a vertical line, this is great for stream. Okay, so if I make a vertical line, right? So I drag this around, I can do the vertical line test really easily. Like the function never crosses the line twice, so it is a function. So this one has a problem. Let me draw some arrows to show you what I mean. Okay, so look right here. And look right here. Okay. So why is this important? You're only allowed to use x values once in a function. That's a rule. So in this case, they're trying to use the x value twice. So that is no bueno. So that is not a function. Here, I did not do enough of those. So I'm going to do that again. I'm going to keep my vertical line. I like that. Hang on. Okay, so here it is. So when I grab my vertical line and I go and check, you can see they're trying to use x values more than once, so that's not a function. So this one, I take my vertical line, and as I scan it, I notice they only use each x value once, so it is a function. Ooh, weird. So this one, the line is a little bit trickier, but you'll notice right here. Okay, so let me draw a line. When x is equal to 7, do you guys see that? That's the problem. They're trying to say that you can have, this is not going to be a function because they're saying that you can have 7, -6. And you can have 7, -7, and that is no. You can't do that. So that is not a function. You can only use an x value one time. That's the rule. Oh, yeah, and this one, they're all using the same one, so no. Not possible. Okay, now we're moving on to our last one. So this is just like that, except it's not a graph form. So we're just gonna look at a table real quick and see, are they trying to use an x value more than once? That's all we care about. So I'm gonna put that, I'll type that out. Okay, so let's see. Are they trying to use an x value more than once? Can the number of students who completed their homework be represented as a function of the homework size? Okay, so I guess the question here is which one is the x and which one is the y? Which one depends on the other? So I would say the number of homework questions. I said the number of students completing the work depends on how many homework questions there are. So that makes these the x values. I guess that is going to be that's going to trip some people up if they mix up which column is which. Can the number of students who completed their homework be represented as a function of the homework size? So the completing students depends on the questions, which means these are our x values and these are our y values. Okay, so 5, 8, 6, 10, 4, 5. Look right there. Bingo. They tried to use 6 twice, and that is no good. What? It shouldn't be. They're trying to say these are the x values? Hang on. Can the number of students, I might want to argue with this one. Can the number of students who complete their work be represented as a function of the homework size? Yeah, I think I'm going to protest that one. They agreed with me that the domain was. Oh, okay. I see. Okay. I missed one important thing. Okay. So no, did I? They agreed with me that the domain, the x values included the 6 twice. Oh, you cheeky person that wrote this. Okay. So here's the loophole. So it's like I'm not wrong. Okay, so yeah, okay. So they tried to use it twice. However, they both go to the same spot. Nah, whoever wrote this one really got me. And check it out. So I need to adjust my decision making here. So okay, so okay. So I was right and I was a little careless. So I didn't bother to check and see that they were going to the exact same y values. So the 2 8s go to 24 and the 2 6s go to 26. Okay, so I'm not gonna do that again. Learn from your mistakes. Can the type of flower be represented as a function of the type of hat? So flower as a function of hats. So the x values are the hats. And the y value is the flower. Beret, Panama, cloche, bowler, beanie. Okay, hang on. Beret happens twice. Fedora, cloche, and cloche happens twice. All right, so cloche goes to violet both times. Beret goes to daffodil both times. Okay, so yeah. So if this is like the same as the last one. So they did overlap some x values, but since they go to the same output, the same y value, it's fine. Can the number of videos Ruby's friends keep in their phone be represented as a function of the number of songs? So videos as a function of songs. $200, $125. So first I'm going to check and see if any of the x values overlap. $200, $125, $310, $172, $215, $260, $120. So there's a $125. That happens twice. Uh-oh. 54 and 66. So bam. Not a function. Because those two x values cannot go to different y values. That is not going to work. Okay. So I'll do some more practice problems tomorrow. If you guys have specific questions, like you're getting them wrong, you don't know why, please contact me, send me screenshots. A couple announcements that I need to make for anyone actually watching the end of the video. I'm gonna do this in big text. Okay, so these are big announcements for Childeberg Middle School next week. Okay, so guys, a couple things. One, Chromebook collection. We're gonna get 8th grade Chromebooks probably Tuesday for all 8th graders. Number 2, locker stuff. Your locker belongings. They've already cleaned out your lockers. I'm not sure what day they're going to let you guys come and get your belongings, but I think it would be the same day they do Chromebook collection and debt lists. So most people okay, so there is a debt list and there are some of you that are on it. Now most people have already paid all their money back. That way the school doesn't have to pay for anything. And we don't want to carry your debt list over to next year. And it will follow you to the high school. So what we need you to do is pay your money back. Some people owe $5, $2, but then there's some people that owe $60, $70, $80 to the lunchroom. So if you get a call, realize it's really serious, you need to handle that. So be looking for future announcements about Chromebook collection next week and about your belongings that were not trashed. The janitors cleaned out all the lockers and anything that looked keepable or that was worth anything, they kept it for you guys. So we'll be getting into that next week. So take care of yourselves, take care of your families, and I'll talk to you guys next time.